Welcome to this video overview of the Washington Shelf Backyard Buoys mooring. We'll start with an overview of the main components, then we'll walk through the mooring piece by piece. This is the latest design iteration as of June 2026. This design may change in the future as we keep learning, and we always welcome input if there's something that has worked well for your community and your buoy. When you first see this mooring out in the wild, there are two components on the surface of the water. The first is the spotter buoy, manufactured by SOFAR. This is 100% of the science. It is taking all the measurements and transmitting them back shoreside. But just having the spotter buoy out by itself would create two problems. First, it's tiny and almost invisible. Second, if it were to get pulled under the water, suddenly your wave measurements are inaccurate. So we pair the spotter with this polyform surface marker. It has more buoyancy, so it keeps the spotter sitting nicely at the surface, and as you'll see, it's very visible. Now, going under the surface of the water, the spotter and the polyform both have lines connecting them to this triple junction. We'll show this in more detail, but this allows the whole mooring to swivel without getting tangled. Finally, a third line connects the triple junction to the anchor. Now we'll walk through the mooring. Starting with the spotter, the underside of the buoy is weighted with a stainless steel ballast ring. This means that all of our hardware connected directly to the spotter is also stainless steel. It's very important that we prevent different types of metals from touching underwater, otherwise the salt will create a battery and the ocean will eat your hardware. This means that galvanized steel, which we use elsewhere in the mooring because it's cheaper and stronger, should be kept away from the spotter and this top junction. There's one exception to this metals rule, and it's with cotter pins, but we'll get to that in a minute. The hardware itself is pretty simple. We use a shackle to connect a swivel to the spotter ballast ring. The ballast ring is designed so the straight pin of the shackle fits nice and snug to minimize chafing, and the round bow of the shackle is able to mesh nicely with the round bow of the swivel. So flip that for a shackle 180 from what's shown here. This alignment isn't critical, but it's a nice feature of the spotter buoy. Then we use a second shackle to connect the swivel to a stainless steel thimble that's been spliced into the top of this line. A plastic thimble also works great here if you prefer. Both shackles have stainless steel cotter pins. The thimbles are the biggest wear points on these moorings and the places where we've seen the most failure, so it's really important to apply chafe protection. We've left this side unfinished so you can see the cross-section. After we splice and whip the eye, we add strength and rigidity with about 1 meter of split hose and heavy-duty electrical tape. You can really use anything here. We've used hose, heat shrink, a piece of old pool canvas. Your primary goal is to protect the line from sagging and chafing near the thimbles. You can also see we've stiffened this side of the line further by applying electrical tape up and over the thimble throat. The line connecting the spotter buoy to the triple junction is 15 meters of 1/4-inch Tenex, which has a breaking strength of over 3,000 pounds. It doesn't have to be this exact line type, especially if it's hard to get a hold of. What we're really trying to do here is strike a good balance between drag, strength, and handleability. Larger diameter line is stronger and easier to grab and manage, but it creates more drag from current, which makes your buoy more likely to drag anchor or wander away. Tenex is also very easy to splice, but it's definitely not your only option. To keep the line out of the sun, we weight it with small pieces of 1/4-inch chain. You can attach these with zip ties, twine, really whatever is on hand. At the bottom of this line, you can see really beefy chafe protection as it goes into the triple junction. The triple junction is one big shackle with swivels above and below. This allows the spotter buoy, which connects to the side of the junction, to swivel 360 around the upper polyform and the lower anchor lines. All shackles and swivels here are galvanized steel. In this case, the thimbles are also galvanized, but plastic thimbles work well. We do see an exception to our touching metals rule here. You can see we've taken out the galvanized cotter pins that came with these shackles, and we'll replace them with stainless steel cotter pins. Stainless steel cotter pins will last longer, and we've seen that the added security is worth a tiny amount of galvanic corrosion. Moving back up from the triple junction towards the polyform, we use 3 meters of nil spin, which is a type of coated wire rope. 3 meters keeps the triple junction below boat props, and the added stiffness of the wire rope helps prevent chafing from anything at the surface. We almost always have Neilspin left over from other projects that we're happy to provide you with, or you can use a thicker line here instead if it's tough to get a hold of. In that case, you'd want to use the same beefy chafe protection we've shown on the other thimbles. Leading into the polyform surface marker, we have another shackle-swivel shackle combination. And again, everything is galvanized except for those stainless steel cotter pins. This connects to 2 meters of 3/8 inch galvanized chain. This chain size fits nicely into a PVC pipe, and we thread bolts through both the pipe and the captured chain links to give the surface marker its structural support. Weights at the bottom of the pipe keep the surface marker upright. Above the float, we make a pick point for recovery. We choker a nylon lifting sling through an eye bolt, which connects to the chain here as well to make a really strong lift point. Finally, at the top of the mast, we have a radar reflector and a flag for visibility. We also recommend labeling the polyform with your affiliation and contact information in case the buoy breaks free. Panning back over the mooring components we've covered so far, we can see both the polyform and the spotter connecting to the triple junction. Our last component we'll go over now is the anchor. The anchor line connects to the triple junction with the same chafe protection and swivel shackle combination we've seen before. The length of this line is dependent on your deployment location, so we use a formula based on depth, tidal height, and wave height. This scope is necessary to both set the anchor properly and to withstand storms. We deploy in about 30 meters of water on the Washington coast and use about 50 meters of anchor line. We whip small trawl floats to the bottom of the anchor line to keep it out of muck and debris. And at the bottom of the line, we have more chafe protection and hardware. Another swivel prevents the long line from twisting. And this pair link is useful for mooring recovery. The anchor line can be pulled up with a crab pot puller, and then running a stopper line from the wide mouth of the pair link to a rail or a cleat can provide support and control as you lift the anchor by hand. We use about 40 pounds of anchor chain. In this case, that's 8 meters of 3/8 inch galvanized chain. And then a final shackle connects the chain to a 35-pound mantis anchor. If your conditions are worse or your bottom type is different than on the Washington coast, you may need a larger or different style anchor. For us, 35 pounds holds well and is easy to lift and manage. That brings us to the end of this video. Thank you for watching. Most of this information and more technical detail is included in mooring diagrams and deployment recovery documentation, which you should also have access to. Feel free to reach out with problems, successes, really anything. We look forward to continue doing science with you.